So, hi, I'm Rosanna Ginhawa from IT2103. So, welcome to my channel. So, first, we have to summarize the chapter 7, which is I will be discuss to you briefly information about chapter 7, which is the IP addressing. So, as I start, so an IP address are hierarchical with network, subnetwork, and the host portion. So an IP address can represent a complete network, so a specific host or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion of the IP address must be identical for all devices that resides in the same network. So the subnet mask of prefix is used to determine the network portion of an IP address. So the IP addresses can be assigned either statically or dynamically. DHCP enables the automatic assignment of addressing information such as address, IP address, subnet mask, the default gateway, and other configuration information. So the IPv4 host can communicate one of the three different ways. So the unicast, broadcast, or multicast also blocks of addresses that are used in internet that require limited or no internet access are called the private addresses. The private IPv4 address blocks are 10.0.0.0/8, then 172.16.0.0/12, and then 192.168.0.0-16. So the depletion of an IPv4 addresses space is the motivating factor for moving to IPv6. So each IPv6 address has 128 bits versus the 32 bits in an IPv4 address. So an IPv6 does not use two data decimal subnet mask notation. So the prefix length is used to indicate the network portion of an IPv6 address. So using the following format, IPv6 address, prefix, and the length, there are three types of IPv6 addresses, which is the unicast, the multicast, and the anycast. So an IPv6 link address enables a device to communicate with other IPv6 that enable devices on the same link and only on that link subnet. So the packets with the source or destination link local address cannot be routed beyond the link from which the packet originated. So the IPv6 link local addresses are in the FE80/10 range. Then the ICMP is available for the both IPv4 and IPv6 IP. ICMP-v4 is the messaging protocol for IPv4. ICMP-v6 provides the same services for IPv6 but includes additional functionality. So after it is implementing, an IP network needs to be tested to verify its connectivity and operational performances. So after I've explained what is the chapter 6 all about, chapter 7 all about, I have a few questions here, which is the first one is how many bits are in an IPv4 address. So as I remember, there is only 32 bits there in the IPv4. So Why? So an IPv4 address is comprised of 4 octets of binary digits, each containing 8 bits, resulting in a 32-bit address. My next question is, what are the two parts, or what are the two components of an IPv4 addresses? So the first one is the network portion, then the next one is the host portion. So an IPv4 address is divided into two parts. A network portion to identify the specific network on which a host resides. A host portion is to identify the specific host on a network. Then my next question is, what does the IP addresses 172.17.4.250/24 represents? So it represents a host address. So it is a host address because usable host addresses for this network are 172.17.4.1 through 172.17.4.254. Then my next question is, what is the purpose of the subnet mask in conjunction with an IP addresses, which is it is determine the subnet to which the host belong. So with the IPv4 address, subnet mask is also necessary. Subnet mask is a special type of IPv4 address that, coupled with the IP address, determines the subnet of which the device is a member. Then my next question is, if a message is sent to all hosts on a remote network, which type of message is it? So it is a directed broadcast. Why? Because a directed broadcast is a message sent to all hosts on a specific network. So it is useful for sending a broadcast to all hosts on a non-local network. Then my next question is, give at least 3 characteristic of multicast transmission. So the first multicast transmission is a single packet can be sent to a group of hosts. And the second one is the multicast transmission can be used by routers to exchange routing information. The third one is the range of 224.0.0.0 to 224.0.0.225 is reversed to reach multicast groups in a local network. So I'll explain. So broadcast messages consist of a single packets that are sent to all hosts. On a network segment, this type of messages are used to request IPv4 addresses and map upper layer addresses to lower layer addresses. Multicast transmission is a single packet sent to a group of hosts and is used by routing protocols such as OSPF and RIPv2 to exchange the routes. The address range of 224.0.0.0 to 224.0.0.225 is reversed for linked local addresses to reach multicast groups on a local network. So my last question is this: an administrator wants to configure hosts to automatically assign IPv6 addresses to themselves by the use of the router advertisement messages, but also to obtain the DNS server address from a DHCP6 server. Which address assignment method should be configured? So for me, it is stateless DHCP6. So I think that's all for this chapter. Uh, Thank you for watching.